Ever experienced an uncanny sense of familiarity with something entirely new? That's déjà vu for you. This mysterious phenomenon, often described as a glitch in the matrix, is a common experience shared by a majority of individuals. Despite its ubiquity, the enigma of déjà vu continues to captivate and confound us, as the neuroscience behind it remains largely uncharted. At its core, déjà vu is a paradox. It's a peculiar sensation where the new and the familiar collide in a moment of unexplained recognition. It's walking into a room for the first time, yet feeling like you've been there before. It's meeting a stranger, but experiencing an eerie sense of familiarity. It's that fleeting feeling of having lived through a moment that's happening for the first time. Now, imagine the brain as a vast, intricate labyrinth. Within this labyrinth, billions of neurons are continuously communicating, forming a complex web of connections. These connections, or synapses, are the basis of our thoughts, memories, and experiences. And somewhere within this vast neural network, the mysterious phenomenon of déjà vu takes root. But where exactly does déjà vu originate? What triggers this uncanny sense of familiarity? Is it a mere glitch in our memory, or is there more to it? The answers to these questions lie within the intricate realms of neuroscience, from the microscale dynamics of the hippocampus to the grandeur of neural network architecture. The exploration of déjà vu invites us on a fascinating journey into the depths of the human brain. Despite extensive research, the precise mechanisms underlying déjà vu remain elusive. But this doesn't deter us. Instead, it fuels our curiosity, beckoning us to delve deeper into the neural labyrinth. It challenges us to unravel the complex interplay of neurons, synapses, and neurotransmitters that give rise to this enigmatic experience. So let's embark on this expedition together. Let's navigate through the mesmerizing landscape of neural microcircuits, delve into the rhythmic dance of neural oscillations, and explore the molecular intricacies of memory consolidation and retrieval. Our journey into the neural underpinnings of déjà vu promises to be a fascinating one, full of intrigue, discovery, and perhaps a few surprises along the way. Join us as we embark on a deep dive into the complex neural labyrinth that gives rise to the enigmatic experience of déjà vu. Our journey begins at the heart of the brain, the hippocampus. This intricate neural landscape is where déjà vu draws its first breath. Picture this. Amidst the ceaseless chatter of neurons, a glitch occurs. Yes, a glitch. That's what the glitch hypothesis proposes. It's a momentary hiccup in the precision of synaptic transmission, a brief lapse in the brain's normally impeccable neural communication. This tiny blip is enough to cause a ripple in the pond of our memory processes, leading to a transient disruption in the encoding and retrieval of contextual details during an experience. It's like a short-lived echo bouncing around in your brain, creating an uncanny sense of familiarity where there should be none. This fascinating theory offers a microscopic view into the elusive phenomenon of déjà vu. So, the next time you experience déjà vu, remember it might just be your hippocampus playing tricks on you. Next, we navigate to the entorhinal cortex, a neural tapestry interwoven with complex microcircuits. This region of the brain, often overlooked, plays an essential role in our understanding of déjà vu. Here, countless neurons engage in a ceaseless dance, orchestrating the flow of information to the hippocampus, our brain's memory center. Each neuron, each synapse, each firing pattern contributes to the intricate symphony that shapes our perceptions and memories. But what happens when this symphony stumbles? When the notes collide instead of harmonize? Could this be the root of déjà vu's peculiar familiarity glitch? By delving into these microcircuits, we begin to see how their intricate dance can sometimes lead to a misstep that sends ripples through our memory processes, giving rise to the uncanny sense of familiarity that characterizes déjà vu. Thus, the entorhinal cortex is a crucial player in the déjà vu narrative. From the circuits, we move to the rhythms of the brain, the neural oscillations. These oscillations, or brain waves, are like the symphony of the mind. They are rhythmic or repetitive patterns of neural activity, primarily within the theta and gamma frequency ranges, that play a pivotal role in our memory processes. Let's delve into the theta frequency range first. This slow, low-frequency oscillation, akin to a bass drum setting the pace, is often associated with a state of relaxed alertness, and it's crucial for the encoding of new memories. It's during these theta waves that our hippocampus, the memory center of the brain, is particularly receptive to new information. Then we have the gamma frequency range. These are the fastest oscillations, the high-pitched flutes and violins playing over the steady beat of the theta waves. They're associated with conscious attention, the processing of sensory input, and the consolidation of memory. These two rhythms, theta and gamma, don't just exist independently. They dance together in a process known as theta-gamma coupling. This is where the magic happens. The slow theta and fast gamma oscillations interact, creating a kind of neural Morse code. This coupling is believed to play a critical role in the temporal coordination of neuronal activity necessary for the successful encoding and retrieval of memories. Now, imagine if this delicate, rhythmic interplay were to falter even for a moment. Suppose the theta waves slow down too much or the gamma waves speed up too much. This could potentially disrupt the encoding of new memories or the retrieval of old ones. This disruption, this momentary lapse in the brain's rhythm, might be at the heart of déjà vu. Of course, this is still a hypothesis, and much more research is needed. But it's a tantalizing idea, isn't it? That the subtle shifts in our brain's rhythm could lead to such a profound and mysterious experience as déjà vu. The harmony and occasional discord within these neural rhythms serve as the backdrop for the fascinating phenomenon of déjà vu. Now let's delve into the heart of déjà vu's origins: episodic memory consolidation and retrieval. Episodic memory is like a personal time machine, allowing us to revisit our past experiences. It's a complex process involving a symphony of molecular and cellular events, all orchestrated by the brain. During an experience, sensory information is transformed into a neural code that the hippocampus, our memory maestro, consolidates into an episodic memory. This consolidation process is essentially the encoding of our experiences into a long-term memory format that can be stored and later retrieved. But what happens when this process gets a little quirky? That's where déjà vu steps into the spotlight. It's thought that déjà vu may arise from a minor hiccup in this memory consolidation and retrieval process. Imagine the hippocampus as a maestro conducting a grand symphony of memories. Now what if, for just a moment, the maestro loses the rhythm? The music becomes a confusing cacophony, and we're left with that eerie sense of familiarity, that feeling of déjà vu. To understand this, let's take a closer look at the molecular intricacies of memory consolidation and retrieval. When we experience something, our neurons fire in a specific pattern, creating a unique neural signature for that event. This signature is encoded into our memory through a cascade of molecular events involving a host of neurotransmitters and proteins. During memory retrieval, this neural signature is reactivated, allowing us to re-experience the event. If this reactivation process is slightly off, we might retrieve a memory that doesn't quite match our current experience, leading to a fleeting sense of familiarity, a déjà vu. The brain's memory machinery is a marvel of molecular precision. Yet, even in this well-oiled machine, glitches can occur. Déjà vu, one of the most captivating of these glitches, pulls back the curtain on the complexity of our memory processes. Understanding the encoding and recall of episodic memories provides a backstage pass to the theater of déjà vu. Finally, we zoom out to explore the grandeur of neural network architecture. As we do, déjà vu invites us to consider the broader symphony of brain regions engaged in this cognitive ballet. This isn't just about isolated neurons or individual brain areas. It's about the interplay, the dynamic conversation that happens within and between these regions, those that are so intimately tied to memory and perception. Take a moment to visualize this. Imagine a vast, interconnected network, a tapestry woven from countless threads of information, flowing in a complex dance of synaptic transmissions. Each neuron, each connection, is a part of the story. They all contribute to the perception of an experience, to the encoding of a memory, and yes, to the peculiar sense of familiarity that we know as déjà vu. In this network, no neuron is an island. Each is a part of a whole, and the whole is greater than the sum of its parts. It's the relationships between these parts, the flow of information, that truly defines the network. And it's this intricate dance of neurons across these networks that paints a holistic portrait of déjà vu. This panoramic view of the neural network architecture invites us to see déjà vu not as a mere glitch, but as a phenomenon emerging from the complex interplay within our brain's architecture. It beckons us to explore the interconnected tapestry that gives rise to déjà vu, to trace the pathways of information flow, and to understand how they contribute to this fascinating anomaly. As we delve deeper into the mysteries of the brain, we begin to appreciate the beauty of its complexity. We see how the flow of information within and between brain regions creates a symphony of neuronal activity, a symphony that plays out in our thoughts, our memories, and our experiences. The intricate dance of neurons across these networks paints a holistic portrait of déjà vu, an enigma that continues to captivate and intrigue us.